All right. After you have gotten everything, you compound the impurities into the solution and the hot solvent. Everything is really hot right now. The next step is we going to crystallize, selectively pick just a compound to make it come back as a solid. We call it crystallizing. Okay. Now the trick is we have to cool down your hot solution to room temperature, and slowly. Slow is really important. Right now you have to be really patient. Okay. I'm going to explain the theory behind it with this game. Have you guys played this game before? Maybe. All right. Most of you probably have seen this game before. I don't know what's it called, brick game or something like that. Anyway, right, basically if you haven't played this game, so like there's a little brick that have multiple shape. It's come down slowly, 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 slowly. Your job is just to control, move left and right to make all the bricks or come together, come into contact, and arrange nicely at the bottom. Okay. Now if the rate of falling down of this brick slow, okay, that's another shape, and this doesn't tell you the next shape is coming. Anyway, if the rate of falling down of this brick slow, you are likely to be able to arrange all the bricks and make them add up to each other nicely. Okay, and if some of you, me as an example, I'm not that patient. I usually change the speed of falling of this brick, and I usually ended up like that. So um, anyway, if the solid that or its particle organized nicely like that, not much hole like that, we call that a crystal. Okay. If you have the solid that have a lot of hole, doesn't really organize as great as the crystal one, it's a solid, but it comes in a different form. We call this precipitate. Okay, you have seen precipitate before. Maybe in Gen Chem lab, you do some precipitation reaction. All right. Now, what is precipitate exactly? I'll take a look real quick. So I have the definition right here. Precipitation is a process by which molecules rapid, quick, and fast, right, from solid in a solution. Usually occurs from a sudden change or decrease in solubility in a solvent. Right. You have done that in the previous lab, like when you have like um, uh, an acidic molecule. We have a negative charge right there, soluble well, happy in water, right? Soluble in water floating around. If you protonate this carboxylic acid, and this guy become in water insoluble form. Well, this guy's in water. Once become water insoluble form, what happened? It precipitate out right away because suddenly change in solubility. Right? Now, some of you may ask, hey, we can make a compound crash out or come out from the solution by just make it become precipitate. What's wrong with make it precipitate? Well, here's the thing though. The precipitate, if you remember, precipitate uh, form from sudden change in solubility, sudden decrease in solubility, and that make holes. Okay, because the solid do not organize nicely, and that allows impurity in the solution crash out as well with the precipitate. My point is, precipitate, well, it's a solid, mostly your compound, but it's not pure. Okay. On the flip side, crystallization is a process by which a solid slowly, patiently forms, which is the basically opposite process from precipitation. Okay, and atoms or molecules are highly organized in a structure called crystal. That's why you see crystal like that. Um, there's a science study how crystal is formed. They call it nucleation. Okay, but we're not gonna get to the detail. But basically, let's say if all this square represents one molecule of biphenyl, that's biphenyl. Um, the crystal are formed by just like each molecule, single molecule of biphenyl get together like that, slowly, slowly on the king or the edge, and that's why many crystals look like needles. Okay, but not all of them. Some of them look like a diamond or look like some other types. There are a lot of types. Okay? Or snow. Snow is a great example of crystal. Okay, and crystal doesn't have to be small. This one is in the cave of crystal. That's what it's called in Chihuahua, Mexico. All right. Now, after the step two, after everything have gone to the solution, your solution is hot right now. All you have to do, not much, take the hot plate out, leave the Erlenmeyer flask with those solution at room temperature, just inside the hood. and let it sit right there. Okay. Now from hot solution, you let it sit inside the hood. What's going to happen? Well, the temperature drops. First thing first, the temperature drops. Right. When the temperature drops slowly, of course, the solubility meter is going to be lower. Once it go below the soluble zone, crystals start forming. Maybe you can't see at the beginning yet because there's not a lot of your compounds have formed big enough crystal that you can see with your naked eyes yet. But yet, wait, just wait. If the temperature lower, go lower, more and more your compounds start forming crystal, start forming solid. Let it sit right there. Let temperature lower and lower. More and more of your compound will start forming. You're gonna see crystal coming out slowly. So be very, very patient. Okay. Now temperature go down until crystal is big enough until you can see it. You're gonna see something like that. Pretty cool. Now really cool, right? No any other technique can do like recrystallization. Only this technique can make crystal like that, right? And now, if let's say even if we have the crystal, this right now is at room temperature, everything's kind of cold, right? That's a cold for us. Okay. If we want more of your compound to crash out to form more crystal, well, we're gonna put it on ice. Make temperature as low as possible. Not too low though, until everything freezes. Okay, not too low. On ice, get all the compounds come out as a crystal as much as possible. Okay, that's it. So basically, this one, this step, you just wait. Like take it the hot solution and everything dissolved already. Bring it out of a hot plate, leave it, just sit at room temperature and see how it goes. All right. Hey, if you guys have your phone, bring your phone ready. Take a video. It's fun. It's fun to watch, and you can post on social media. Okay, it's fun to show your friends and family. Right. Remember, only chemists can do this. No other science can do it like we can. You get to do it. So have fun and enjoy. All right, next one, I'm going to go to the last step is to isolate crystal from the solution.